Page 86, homework, AP Physics, problem number 66. I've drawn a little diagram here. That triangle is supposed to be the little rocket. In two stages, it burns fuel for a while, then when the fuel burns out, kind of in the middle of this diagram, the rocket then slows down and stops at the top spot. The total height here is 1,510 meters. So there's two parts to the problem. There's part one while it's burning fuel, and it's uniformly accelerating. It's not decelerating due to gravity, but we do have a V initial of 0 meters per second and a V final of 100 meters per second. 1.0 times 10 squared is 100. The acceleration we don't know. Don't assume it's 9.8 or negative 9.8. It's not due to gravity because it's burning some fuel. We'll call this S will be S sub 1, and then T we do not know yet. Then in part 2, however, and we'll connect these together in a minute, but in part we have a V final that is, a V initial that is the 100 meters per second. That's the V final from part 1. And the V final here is going to coast to a stop, so it's going to end up at 0 meters per second. And now the acceleration, and we'll use the rounded off value, negative 10 meters per second squared instead of negative 9.8, because it's slowing down. And then we have S, which will be S sub 2, and T is unknown. Once again, kind of a quick look, you can maybe approximate this, but if you're slowing down from 100 meters per second to 0 meters per second at a rate of 10 meters per second each second, it's going to take you 10 seconds to slow down. So we can actually look at this one and figure that out if we're doing it in a rounded off value. If you want to actually write this down, you could use the first equation. If you want to write it down officially, but V sub F equals V sub I plus AT, V sub F being 0, V sub I being 100, plus negative 10 times T, so T would be 10 seconds. And then you need to plug in and figure out what your S is. So you could figure out using one of the other equations, probably the third equation, that S, sub 2 is going to be equal to V sub I times T, so 100 times T, which is 10, plus 1/2 AT squared, so negative 10 times 10 squared. Let me pause and do the calculation. And that comes out to be 500 meters. I ran out of space down there. You could have also just found that by just V average times the time. The average velocity is going to be 50 meters per second for 10 seconds. So that's 500 meters. I've rounded off the numbers here enough that you could do a lot of this in your head. So going back over to part 1 now, combined with my diagram, in my diagram I have the total height being 1,510 meters. But in part 2, this upper part, I know that this is 500 meters. So therefore the lower part must be 1,010, or basically 1,000 meters if we start rounding off a little bit. So S1 is 1,000 meters. And then find the appropriate equation to figure out what the acceleration is, or actually we're looking for T. We already found how far it was when the engine cut off. In other words, when the engine burned out, it was at the 1,000 meter mark when the engine stopped burning. And just once again, I'd say use first equation for uniform acceleration to figure out how much time it took to get to that location.